So polynomial functions. So remember I said it gets harder from here? Except for this chapter. Oh, you grabbed the whole thing, huh? Anyone else need a sheet? Vanessa needs one right there. You could give her one. Anybody else need a sheet? You right here. She's got them all. All right. So if we have positive x, I'm just going to put it in the graphing calculator so you can see what it looks like. So if we have positive x cubed, I think it was, is it 3x squared, the first one?
Yes.
3x squared like that, and I hit graph. Looks like that, right? So when we sketch the graph, let's go ahead and sketch that. So if I have x to the fourth, it just gets a little flatter at the bottom and goes up. I find it helpful for me personally to put arrows on the end. If it's negative 7x to the 6, kind of goes like that. It's still curved at the corners. That's right. Still curved at the corners, right? But your calculator is a limited number of pixels, so it'll kind of look squared off, but it's not truly squared off. If I have negative 4x squared, it looks like an upside down parabola or a U, like that. Again, arrows on the end are helpful. X to the 7th goes like this. So I want you to think about like a positive odd person in your life, and they're unusually happy, right? If you're a negative odd person, you're like Debbie Downer, right? Always bummed and complaining and whining. So Debbie Downer looks like this. Finishes down. Debbie Downer again. Finishes down. It's not exact drawing, but close enough. That's all we need. So this one finishes up like that. Let's get this. There's one annoying part of this. Let's just get it over with now. So this part right here, we need to write this at the bottom of all of these, which is annoying but true. I've got the handy little thing where I can just duplicate it and drag it. So just write this at the bottom of all of them because you got to do it. On the test, I'll have it written for you so you won't have to do this, but you just got to do it on this part. So just write that at the bottom of each. So it's always this x goes to positive infinity on top, comma f of x. And then as x goes to negative infinity, comma f of x. We'll just get that annoying part out of the way right now. And then we'll keep talking about the rest of that. Got 4-day weekend coming up. It's always a bonus. Rest and recharge. So if you think about this, right? We've got block day next week and Friday. And then we have the week after that is the week before Thanksgiving break. And then after Thanksgiving break, we have 2 weeks, then finals. Okay? So it's going to happen really fast at the end of the semester because the holiday breaks a little sooner than sometimes it is. Last couple of years, it's been like the 22nd when we get out, and it's earlier this time. So put that phone away. So just know the semester is going to come rapidly to a close. So think about that in all your classes. You know that except for my class, you're going to have tests right before Thanksgiving break in pretty much all your classes, right? So my class, you won't. We finish chapter 4 the Friday right before Thanksgiving break, and then we review the Monday after and take the test the Tuesday after, which is not ideal, but this test is a little bit easier. The chapter 5 test, we do part of chapter 5 at the end of this semester, and then from there, chapter 5 is nasty, okay? So it'll get hard. Then we do logarithms and all sorts of crazy stuff. All right, so let's finish off this chart above. So we're on the end behavior. So end behavior means what happens at the end of the function, right? So this says as x goes to positive infinity. So as x goes this way, what's y doing? Going up or down? Y's going up as x goes this way, right? So we write positive infinity right here. And as x goes negative, what's y doing? It's going up or down? Up. So positive infinity again. So we're going to fill out this whole end behavior chart. This one's the same thing, right? Both positive infinities because it's going up on both y's. This one's going down on both y's, so negative infinity on both. The next one down is the same, negative infinity on both. Now we have one of each, right? So when it's an odd exponent, you always have one up, one down. So as x goes this way, where's y going? Show me with your hand. Right? It's going up, so positive infinity for the first one, negative infinity for the second. They will always be one of each when it's an odd exponent. Okay, so this one's the same, positive infinity, then negative, because the shape of the graph is the same. The next one is reversed, right? So as x goes positive, y's going down. So the first one's negative infinity, and then positive infinity. So if you think about when this test is going to happen, and we're doing this Friday, November 7th, I think it is. Yeah, Friday, November 7th. It's going to be a long time. You're going to look back at this so you can remember how this works, right? Because your test is until after Thanksgiving break, which is like a month from now.
You mean December 7th?
No, I mean today is November 7th. And then we're going to take the test after Thanksgiving break, which will be probably in December, yeah. So negative infinity, this one's the same, negative and positive. Like that. Okay? Still working that fun? I see that arm down there. Leading coefficient. What does that mean, leading coefficient?
The 3 in the first one.
It's the number in front of the highest exponent. Not hashtag number. That's what that used to mean. Still means number in front of highest exponent. So you can draw an arrow from leading coefficient, number in front of highest exponent. Okay, so the number in front of the highest exponent, is it positive or negative? We're not saying what the number is, we're just saying positive or negative. Next one is positive. Then we have two negatives. This number would be a 1 on the x to the 7th one, so positive, positive, negative, negative. Okay, so after that, we're just talking about whether the exponent, the degree is the highest exponent. So is the highest exponent even or odd? First one is even. So we got even, 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 and then all odds. Okay. Okay. So for me, this chart is the easiest way to remember it. This chart is not. It doesn't really work for me. I don't like all the words, right? So we're going to show examples below because I think the words with the examples, it'll make more sense. So first two blank spots up top are both evens and then both odds. I'm going to go get in my recycle. Okay, so we have even positive and even negative. So positive in the second blank spot in the first box, and negative in the second one, and then we're going positive, negative here. Okay, so if it's even positive, we're going to give an example like that. So like 2x squared would be like this, up, up. So even negative would be like negative 2x squared would be down, down. Odd positive finishes up. Your odd positive friend that's unusually happy, right? Versus your odd negative friend, which is always like, life sucks. Don't be like that. Just be happy. It's easier. Are you talking about your sister again? It's not nice. All right, so I'm just going to move these over because I wanted to write the examples in front. So this would be like odd number, so odd exponent, positive. So like 2x cubed. I'm just using the same number every time. It's just, the 2 doesn't matter, right? It's just whether it's odd or even, the exponent, and it's positive or negative, the number. So this one is going to be both positive infinity, the first box. Second box is going to be both negative infinity. We're just giving you like 3-4 different ways to do all this, right? It's all the same stuff. So odd positive as x goes positive, y goes positive. And as x goes negative, y goes negative. And it's opposite on this one. Negative infinity for the y, and then positive infinity for the y. Like that. Yep,
Could you go to the top for a second?
I can.
Thanks.
No problem. You need to see that.
Yeah.
Gotcha. Leading coefficient. Coefficient just means a number in front of the variable. If there's no number, what's a coefficient? 1. Okay? Just making sure, like we've said that many, many times, right? But we'll keep saying it till you get it. So is my leading coefficient positive or negative on this one? Actually, you guys fill out the chart. And then you can check your answers in a sec. You try it. It's negative or positive, even or odd. So leading coefficient is either negative or positive. Degree is either even or odd. I like filling out a column at a time. I find it quicker, but you do you. Checky. We good? All right, last two. All we got to do is plug in values and graph it. That's all we're doing. So I'm going to fill out both of these x's just like this. Right, same thing on example 2. I could have picked based off the denominator of that fraction, like -4, -2, 0, 2, and 4. Doesn't really matter because the math is still not that hard. And so I'm just going to plug into the function over here. You got to show your work. And I would just plug all of them in first and we'll do the math after. It'll be faster. If you can do it in your head, congratulations. Show the work anyways. You think like every opportunity you can get to get partial credit, you show that work, I can give you partial credit when I grade your test, right? That's why you do it. Okay, so we're going to plug it in. We already plugged it in. We're going to do the math now. -2 times -2 is 4. What's 4 times 3 over 2?
6.
6, right? 12 over 2, which is 6. So I know I'm going to get a 6 down here as well, right? Because math has patterns. You can do less work because it has patterns, right? So if I do -1 times -1, that's 1. 1 times 3 halves is 1.5 or 3 over 2. I find it easier to graph 1.5. So I'm going to do the same thing down here. If I plug in 0, I get 0, right? So I'm going to graph those. So 1.5 right there, 0, 0, 2, 6. And then draw your parabola. It's just that easy. Don't make it any harder than that. So what's the domain of any parabola? All reals. Let's remember for interval and set notation, which I've talked about all year and some of you forgot, right? If I write this in interval notation, we always go low to high. I already made a mistake. What should it be? No, that's set builder. The squiggly thing is set builder. Interval, it's got to be squared off, right? Because it starts and includes 0. Starts at 0 and includes it. That's why it's squared off. And where's it go to? Infinity. And it's always curved at infinity. Or that was, and I just wrote it in the wrong place. That is the range. Sorry. I meant to write that right there. So if I don't specify set builder or interval notation, you could write this. Is it y is greater than or less than or equal to or not, and 0? What is it? Y is greater than or less than or equal to?
Greater than 0.
Greater than or equal to 0. And if I just want to make that into set builder, all I have to do is this. And then I just write y such that y, and I put the weird looking bracket thing. Looks like a sideways bird. That's set builder. So if you don't remember that set builder, put SB next to it and put interval next to this one so you remember which is which. Set builder has a weird, it's kind of B looking, the bracket thing. Okay, let's plug this one in. -1/2 times -2 cubed, -1/2 times -1 cubed, etc. This one also has a pattern, but it doesn't exactly repeat. It goes positive to negative, right? Because our negative cubic finishes down. So the general shape should be something like that. Okay, it won't curve quite that much in the middle, but it'll be relatively that. Easiest one to do is the middle one, because I plug in 0 and multiply by anything, it's still 0. So the top one, if I do -2 times -2 times -2, I get -8. Times -1/2, 4. So this one would be +8 times -1/2, so that one would be just -4. So the next one is going to be what? -1 times -1 times -1 is -1 times -1/2, 0.5. You can write 1/2 or 0.5, either one's fine. And this one's going to be -0.5. So that pattern won't always work with these things. If we had like adding and subtracting in the parenthesis, that moves it left or right, and then it gets all messed up. But for these ones that are centered around the origin, it works like that. So -1.5. So that's what the middle looks like, and then the 4 there and there. And then when you draw it, give it a little bit of a curve, right? But if it's wiggly and not perfect like mine, that's fine, right? But if you make it like harsh straight lines, then I'll take points off for sure. What's the domain of this thing? All reals, right? Because it's angling out, up and down, and it also goes up and down forever, right? So that's also all reals. Now I want to write set builder in all real number form because people forget that one. It's got that funky looking E thing. Element of, you make a C and then you put a little E dash in the middle. So element of is what that means, all real numbers. And then you just make your little bracket at the end. Okay, that's set builder notation. Interval would just be like this, negative infinity to positive infinity for all reals. That's interval. Okay, so you'll see that on SAT. You'll see it for the rest of the year. So we have the semester planned out. There are 4 sections in chapter 4. So we'll do those 4 sections. Some are 2 days, some are 1 day. Depends if it's a block day or not. And then we'll finish at chapter 4 right before Thanksgiving break. Take the test the Tuesday after Thanksgiving break. Right? So don't just totally vacate your mind over break. Otherwise that test won't go well. And then we'll do 5-1, 5-2, maybe 5-3, we'll see. And then you have to take district ALEKS assessment, which counts towards your grade. Okay? And then you're going to study for my final and take the final. Okay? The final schedule is different than in years past. You've got a tutor session before each final. So every single final has I don't know how long it is. I don't remember. We looked at too many different schedules. But there's a little tutor session before each final. So any of those tutor sessions, whether or not you have my final the next period, I'll be here and you can come in if you need to. All right, that's it.